What's going on, y'all? It's Daniel Litwin, the voice of B2B here at the Premio booth at ISC West 2025. And today we're sitting down with the Premio product marketing team to do a little product comparison, a little myth busting, and a little diving deep into how each of Premio's main product suites can serve the security and surveillance industry. We're doing an RCO versus BCO podcast. No fighting, guys, okay? No blood. We're saving that for later, okay? We're throwing down later. Welcome to the product marketing team here. We're joined by Mr. Colin Wu and Ethan Dang of Premio. How you both doing?
Good. Looking forward to what we're going to talk about.
Yeah, man, same. Thank you for joining us. So the main reason we're doing this little podcast is because the Premio product suite is very diverse.
Yep.
But we need to understand, especially our audience, what differs between the main product lines. Where do they fall in what we call the edge continuum? What use cases do they actually serve in security and surveillance? Which ones are rugged, semi-rugged, industrial, etc.? Why don't we start with a little high-level overview on what even are the RCO series and BCO series, right? Break them down so our audience understands what we're even comparing.
Yeah, so kind of give a high general overview for both of them. Our RCO and BCO is our x86 industrial computer line. So both utilize that x86 architecture. The only, caveat difference is that, as you mentioned, is one of them is a super rugged line and the other one is semi-rugged, but very, very similar in both in terms of capabilities and the way they can, process data.
Yeah. The way it's really diverse is where it's actually being deployed. So you're seeing the RCO being deployed in more extreme environments, while the BCO kind of sits back in more controlled environments.
Nice. All right. So big distinction immediately. We're seeing rugged versus semi-rugged, right? And that semi is carrying a lot of weight in the conversation. What actually distinguishes a use case from being rugged versus semi-rugged? How do y'all make that distinction when you're guiding your clients?
Yeah, I'll go first. So Premio has been working with industrial computing for almost 35 years. And we've really identified that there's three key categories in edge computing. There's really no one size fits all. All these different types of organizations and companies are looking for very specific computers that will meet their deployment demands. So in the three categories, we have rugged edge, which is the extreme environments, the industrial edge, which is more controlled environments, and specialized edge, which is very application-based. In the industrial edge, you're seeing something more in like an airport kiosk where the application is still mission critical and it needs 24/7 operability, but it doesn't need the extreme ruggability of being deployed in like an extreme outdoor environment. With rugged edge, you really see extreme deployments where they're high risk assets. There's a need for mission critical applications, and there's no accessibility for a maintenance crew. For example, wildfire detection on top of a mountaintop.
Nice.
Yeah, there's no easy way to get there unless you want someone hiking up the mountain every single time to do maintenance.
I can use cardio. You can send me there. Yeah.
Yeah. I mean, I can use the hiking too, but that big distinction is really key in a lot of these applications, like Ethan mentioned, because that really sets a really big indication on how people are deploying. Because just something that a lot of people may not think about, something in terms of remote location, it's going to make a big drastic decision on their costs and all how they're going to operate. So, wildfire detection, in his example, you're not going to be wanting to hike every single time just to fix an issue. You want to be able to remote in, you can access that immediately, diagnose your errors, and get onto operating reliably in that mission critical environments. Whereas on the semi-rugged side, it could be a factory floor. You typically may have employees who are already sitting in that space who are able to see the diagnostic problem, able to access it quickly, do the routine maintenance and keep the operation going. But both of them still have to operate reliably, operate in an environment where it's not in a traditional space that's safe for a traditional IT infrastructure or traditional desktop computer.
So thanks for breaking that down in more practical terms. Now let's look at performance, because even if some are, needed in rugged versus semi-rugged environments, you mentioned it, right? these are still environments that need constant uptime, where you're going to have computers running at odd hours, 24/7. How do these two series compare in terms of processing power to handle the realistic use cases where they're going to be deployed?
I think for both series, it's pretty similar.
That's what I was thinking.
We follow this. We follow this form factor design, or we have 136. But with the BCO, we have the introduction of a BCO 500. But that aside, it follows a very similar performance structure. The most smallest compact ones is going to be using a system on chip design. So it could be built around a single board computer or a very small motherboard where you are implementing that whole module on there. And those are always typically low power, but still able to output enough performance in terms of places where you don't need a lot of extreme high performance capabilities, but it's still enough to perform the functions, perform the necessary applications and workloads. And as you scale up, as you move to the 3000, as you move to 6000, you're moving from, in our case, for the 1000, 3000, you're moving from system on chip to a socket type performance. And that's going to give you even more higher performance with, our x86 is an Intel Core processors. And then as you scale even further up, you have the ability to add on AI accelerators, hardware accelerators, like a GPU or even M.2 AI accelerators. And I think that's just pretty much the same for the RCO, but RCO obviously has a little bit more bells and whistles when it comes to scaling up. And I think Ethan has a little bit more better picture on how that kind of works with the RCO series.
The 1000 is using an Intel Atom, right? So it's only outputting about 12 watts of TDP. It's following the embedded product lifecycle for 10 years of deployment consistency. And as you move higher, you're going to get much more power, like Colin said. You're going from an Intel Atom processor that's very power efficient to the Intel Core, where you're getting, with the latest Intel architecture, the hybrid core, you're getting the P and E cores, performance cores, and efficiency cores, just to process all that heavy, complex, multi-model AI workloads.
What I'm noticing is that regardless of the super, hardcore rugged environment or semi-rugged or industrial, you're still needing an edge computer that can handle increasingly intense AI workloads, a lot of data capture, processing at the edge in real time, no downtime. So it makes sense that a lot of the processing power under the hood is actually starting to look rather similar across the product suites. Right. So that's interesting to see. Now, what about connectivity and I/O options? I know there's a lot of variety there, especially when you look within each suite, the 136, you see some variety there. But if we compare at large RCO versus BCO, what do the connectivity and the in-out options look like between the two?
Oh, this is where we fight. No,
hold it back, guys. Come on, careful. Yeah.
No, this is where we kind of get different.
Okay.
So, I'll start with the BCOs.
Yeah.
So BCO connectivity, it's on board. Yeah. So everything that the board is providing, whether you're pulling out from headers or whether it's from the rear I/O, that's what you get on the BCO. So USB, the USB, the LAN, the serial legacy COM ports, those are just dedicated and those are provided right then and there. There's no actual room for modular expansion that you're going to see in a lot of other types of industrial computers.
Yeah.
But that's enough for a lot of people in a lot of cases or unique environments where maybe three US or 4 USB, 3 LAN ports is exactly what they need. They don't need any more, any less, and it kind of covers exactly their requirements. So for the BCO, that's kind of where we play into that strength is we give you exactly what you need on board. You don't need to probably cough up any more of your paycheck or your bankroll to accommodate anymore. So that's where I think the BCO really shines in terms of I/O connectivity.
Yeah. So the BCO, just to follow up on Colin, the BCO has very fixed I/O. Whatever is on the BCO, that's all you're going to get. This is very traditional and it makes sense, right? You're still getting IoT centric connectivity, right? But you're not getting that modularity that you might want. But with the RCO series, that's where we have edge boost technologies, which is very proprietary to Premio. We're able to meet any type of deployment requirement with edge boost technology, whether it be for additional LAN ports, PoE support, as well as COM, etc. And that's kind of how the RCO plays is if you require additional connectivity or you need a special PoE capabilities, the RCO is where you get upgraded and have that capability.
How do the features differ when we look at security and also management of the edge computers between the RCO and the BCO? And how do you see them benefiting industrial deployments?
So I think that no matter what happens, it's kind of like the processing power. It's an industrial computer that uses x86 processing. So there's not really a difference in performance. Same with the security. We're always making sure that it's tamper-proof. It's meeting all the different types of qualifications and certifications. For example, all of our products here are at least UL listed. It's been through the test. It's been tested and validated by UL to make sure that it's following all the safety standards compliance, and it's ready to be deployed. It's also NDAA and CA compliant. So you're making sure that all of these different types of products are being made in a correct regional standards.
Yeah, I think it's important to actually note is that there are similarities in our computer, in the BCO and the RCO. There's the security features as well. So, across the board, we have TPM 2.0, so discrete ways to protect data. And now we have secure boot, discrete ways to actually keep this computer safe from intrusion. And I think the RCO also has additional abilities, like it has the data storage canisters where you can add, little locking screws on them to even further protect from actual physical intrusion. But I think the key point with security really is that, especially at security surveillance show that we're at right now, is that there is a bottom line, kind of a standard that has to be met.
Right.
And in order to be a key player, in order to be a key manufacturer of industrial computers, in security surveillance, in having to meet all the criteria across the board is probably the most important for us. So everything from certifications from UL listing, all the way down to the actual physical intrusion or detection is the most important and most prevalent thing that we have to kind of consider as an industrial computer manufacturer.
Right. Yeah, and just to add on, Colin mentioned the Edge Boost nodes supporting the safety lock and the ejection feature and the anti-tampering feature. Our products, both RCO and BCO, ensure that we have localized data storage, right? And that's really important. There's humongous trends that are growing where cybersecurity attacks are becoming more prevalent. And in order to prevent that, you need to have localized data storage. You don't want to send mission critical, high risk asset data to the cloud when it could be intercepted, right? So that's kind of where the RCO and BCO play, is localized data storage, ensuring data privacy, and et cetera.
Nice. Makes sense. Yeah, definitely. Especially in security and surveillance, a lot of sensitive information. But now let's talk deployments and use cases, right? This is what I really wanted to get to. In terms of real world applications, can you share some examples of how you're seeing customers out there use the RCO versus the BCO series, right? In creative ways and ways that are pretty, part and parcel with the design of the product, right? How are customers finding value in distinguishing between use cases between the two series?
One of the most unique ones, does not necessarily have to do with security surveillance, but definitely with our BCO is, we had a customer that was very, very interested in the way the BCO 6000 is kind of designed in terms of the form factor, that slim height, in a way. And that was actually perfect for them to integrate into their overall solution. So for them, we kind of, we were able to take the chassis that BCO 6000 was built around, use that as kind of the base to integrate into their use case, for their operations. So I think just even something like, the physical dimensions of the BCO, can play a big factor into how people are implementing their workload, deploying at the edge.
Yeah. And for, like Colin said, the BCO is very cost efficient. And that's what all our customers are looking for. Cost. But sometimes in deployments where you really need reliability, you need to pay that premium to meet those type of reliable demands.
Yeah.
So my RCO 1000, for example, it's very ultra compact. It's balanced and cableless. It has a proprietary motherboard, and it even features Edge Boost IO. It's being deployed in mobile surveillance trailers, out in top of mountaintops and parking lots, etc. And these are all exposed to outdoor environments. While Colin's BCO is kind of sitting inside of like a little house or a warehouse, etc. They're both mission critical applications, but mine is just more outdoors and more extreme.
I like to be comfortable though, the BCO. See, we can be comfortable.
Right. And just to add on top of that, the RCO 3000 and RCO 6000, and I really see the RCO 3000 playing as a IoT gateway, especially in wastewater management, where you really need to have multiple types of access controls, monitoring and logging, etc., to really be confined into a centralized hub. So the RCO 3000 is able to meet IoT surveillance cameras for access control and surveillance. It's able to have monitoring capabilities by connecting different types of wastewater treatment centers. And it's able to just provide all the different types of real-time performance needed for wastewater management.
I'm curious how Premio works to design both the RCO and the BCO with that future in mind, that modularity, that innovation, pressures from the market and the industries that are going to kind of reshape, the use cases of the products themselves. How do you all design with the future in mind?
That's a lot of research, really.
Yeah.
It's research. I think it's research, feedback, and really paying attention to these markets. For us, we cater to so many different verticals. So being able to understand their pain points, their unique challenges allows us to future-proof. And not only that, we also follow, a lot of embedded roadmaps, such as, Intel's or NVIDIA's roadmap. We're able to stay on top of their latest semiconductors for processing power. Right. So having that combination, understanding the unique demands that people are looking for allows us to future-proof. So for the BCO example, I think one of the biggest ways we could kind of future-proof and scale for a lot of the new challenges that can happen is that the BCO is built around very standardized form factors. So on the 1000 and the 500, you have a standard 3.5-inch SBC, and that's common across the board in a lot of places in the market. So be able to build a computer around that type of form factor and scaling up to a mini ITX on the 3000 and 6000 allows us to not have to worry about designing a full proprietary board that you're going to see in the RCO. That's a lot more research and engineering involved in there. But for the BCO, that future scalability is there. So we're able to say, what's the next generation of Intel processor that's coming on the x86 architecture? Okay, well, you can build around that, and then we can build around the next chipset and et cetera, et cetera. So that allows us to scale easily into the market to provide exactly what they need on the processing power. Yeah. And then same for the IO and as you build for the future.
And for the RCO, it's really important because we've kind of already built it to be future-proofed other than the processor itself, which Intel kind of provides. Our idea of having edge boost modularity with the edge boost node featuring a GPU or NVMe or just fully NVMe really allows the customer to be able to configure their RCO series to meet all types of deployment requirements. Like I said before, Edge Boost IO supports for LAN, PoE, etc. You're able to swap in and out and meet the future trends. For example, there's a Edge Boost IO that supports dual 10 gigabit E LAN. And a lot of customers are like, we need a computer that has that capability. We're having the latest IoT camera that needs that type of bandwidth to meet the deployment. And our RCO or RCO 6000 and 3000 are able to meet that demand because it's a simple module that you pull in and out. And same with the Edge Boost node. A customer utilizing license plate recognition for their tolling systems, that was pretty brand new at the time. And we were able to easily accommodate them because our Edge Boost node was one of the industry leading features was having up to 8 hot swappable NVMe drives. And we're able to store all that data while all the other current offerings weren't really able to meet that demand other than having an actual dedicated server. But the customer really needed something that's more reliable, more rugged, and an industrial computer. So that's kind of where the RCO plays for future-proofing and scalability.
Nice. So last question then to wrap things up is if you were approached by a customer and they had questions around both of y'all's product lines, they're trying to figure out which one is best for them. What are the questions that you think someone leveraging Premio's rugged edge computers should ask themselves to identify which series is best for them, right? How do you guide someone to identify the right fit?
Yeah, so I think there is a good baseline to figure out how you want to configure your industrial computer. There are 4 quadrants that we've identified, first being ruggedness. Obviously, if you're trying to deploy an industrial computer in an outdoor environment, you might want to look and consider the RCO. But if you're comfortable with not having those extreme operating temperatures and shock and vibration, you might want to consider the BCO, especially with the durability. Next, you have performance. It just depends on what kind of workloads you're running. If you're running a complex AI workload, maybe the RCO 6000 is the play because it supports that specific GPU, while the BCO 6000 might not support that. It's not capable of supporting that specific GPU. Same with modularity and scalability. You're able to think about whether you need more than 4 or 3 LAN ports. If you need more than that, then maybe the RCO is the way to go because we have modular edge boost IO to support that. And the BCO has a standard 4 or 3. So if you don't need to go any higher than 4, then why spend so much on the RCO when you could really focus and hone down on a very cost efficient product?
There's so many other questions that I think customers will have to really ask themselves when it comes to their requirements, and understanding what they need specifically from their own deployment is key.
Right.
It's not one single answer, one size fits all. So, are you going to be spending, a lot of money to implement your deployment? And then is that something that you're going to need, in terms of performance? So do you need GPUs? Do you need a lot of storage? Do you need something along those lines?
Right.
And I think just the starting question really is, are you trying to be cost efficient on your deployments? Are you looking for something that's very simple, very standard? And is your deployment in a controlled environment?
Right.
And then if you need something that's ruggedized, it's harsh, it's because you're in a remote location, that kind of already puts you down the right path of whether it's going to be RCO or BCO.
What's great is that even if there is a lot of modularity, there are some unique needs from a client, these are out-of-the-box solutions that are ready to plug in and make best use of. So I love seeing Premio continue to set standards, not only in terms of customizability, but also ease of use and truly, pun intended, black box style deployments for your rugged edge computer. So great stuff. No fists thrown. So this is the
Only fist bumps.
Yeah. Oh, just fist bumps.
Yeah.
Wow. Unity. This is the tamest verses I've ever seen. So thank goodness. But we are throwing down later in the parking lot after this. If anyone wants to come watch, it's going to get intense. All right, everyone. RCO versus BCO. Thank you again for laying out the differences. If folks want to learn more about either product line or even your JCOs, where can we point folks to learn more?
Everything's on our website at premioinc.com. So go visit there. It has everything that you need from our product solutions all the way to our thought leadership content, such as this podcast.
Yeah, love it.
We definitely have a very dedicated sales team, very knowledgeable to really meet any type of demands that you're looking for. That way you don't have to do a lot of the research or the homework. We will do it for you.
Love to hear that. Again, Premio Inc., premioinc.com. Head to Premio's LinkedIn page for more. Again, we've been chatting with Colin Wu and Ethan Dang. Thank you, Colin. Thank you, Ethan. Much appreciated. Yeah. Thank you, everyone, for tuning in. More interviews, panel discussions, and deep dives from ISC West 2025 coming your way.